All right, so let's go over some of these problems in 1-6-3. So it says use the graph of y equals f of x given below to answer the questions. So it says find the domain in f. So remember, domain, that's as if you take your graph and you project it, project, and you get it flat along the line. And then you look at where it stops and where it ends. And so it starts at -5 and it ends at 3. And because they are closed circles, we know that we are going to have brackets. And then I'll clean that up a bit. Find the range, same idea, but now we're doing that. Right, everything's project. So it's all solid. There's no gaps or anything. And so that's going to be from -5 to +4. It says determine f of -2. So it's saying what is my, because remember f of x is your y value. And then it's, if I plug in a value for my x, what is my y? That's what it's saying. So if I plug in -2 for my x, what is my y? And that's going to be 2. Now it says solve f of x equals 4. So remember, if we're looking at this statement here, f of x equals y, well, what changed? The 4 did. So this is f of x equals 4. So it's saying if I know my y is 4, what's my x value? So I need to go to where my y is 4, and that's going to be -3. The x-intercepts, that's where, it crosses the x-axis. The y-intercepts is where it crosses the y-axis. The zeros are like the x-intercepts, except it's where, we don't include it as a point. We just say the x values themselves. Here's a nice one. Find where your function is greater than or equal to 0. So if we have our graph and we know that your y value is 0, right? F of x is y. It's saying where is your y values greater than 0? So where are your y values greater than 0? So looking at this graph here, this is all greater than 0. And so the values here, that would be between -4 and -1. Those are all going to be greater than 0. And then from -1 to +3, all of that is going to be greater than 0. And so we can say union, is that 1 to +3? Yeah, 1 to +3. Now, just to note, if it didn't have an equal to, that means you couldn't include the 0 itself, which means you would have it as open circle. Then it says list the intervals where your function is increasing. So remember, that means that if you start moving this way, is your graph going up or down? And so from -5 to 3, my graph is going up, so that's increasing. From 0 all the way to 2, my graph is going up, so that's increasing. And so we would say that that's an interval. Those two intervals are increasing. It says list the interval where it's decreasing. Same thing, but it's where it's going down. So from -3, decreasing. Find the maximum. So the maximum is going to be the highest possible value. So that's going to be 4. Now the local minimums, remember, a local just means any interval that we can create. So if we have an interval, we know that there's a lowest possible value. So any local minimum is any time the graph goes down and then goes up. If we see a place where the graph goes down and then goes up, we have that a minimum. So this right here at -1 is my local minimum. Now likewise, here and here, those values there, that's where your graph goes up and then down. Those are going to be my maximums. So my local maximums are going to be 4 and 3. And you can have more than one local maximums. The only thing, and same with local minimums, the only thing is the ends of the graph can never be a local max or min, because it has to either go down and up or up and down. For this instance, there's no down and then up, right? It's just there. And this likewise here, there's no like up and then down or down and then up. It just doesn't exist. So therefore, they can't be local maximums. Now another phrase that you're going to see this is this phrase extrema. Extrema means max and mins. Determine analytically if the functions are even, odd, or neither. Okay, so remember, if your function is going to be even, this statement has to be true. F of x equals f of negative x. So if that statement there is true, then we know that it's going to be an even function. And then an odd function, we have to prove that this statement is true. And if you can prove that's true, then we know that the function is going to be odd. So let's look at number 3, even. Does my function equal the same thing with a negative plugged in? So 1 minus x, does that equal 1 minus, now I'm plugging in negative x. So this becomes 1 plus x. Are those equal? No. So therefore, it's not even. So those are not equal. Now let's try odd. So it's going to be f of negative x. So 1 minus, so is it odd? So f of negative x. Does that equal negative f of x? And so does the square root of 1 plus x, does that equal the negative square root of 1 minus x? Those are not the same, so those are also not equal. So it's not even, it's not odd, so therefore it's neither. Sketch the graph of the given piecewise function. So if we're sketching it, it's a good idea to label the boundaries. So I have a boundary at -2. I have a boundary at, so -2 and +2. So it's x squared when it's x is less than or equal to -2. Okay, so if I create an xy table and I were to plug in, let's just say 0, I know I get 0. If I plug in 1, or sorry, -1, I know I get 1. I'm just not going to draw it in or sketch it. If I plug in -2, okay, so that's where it's going to start. That gives me 4. And then if I plug in -3, I'm going to get 9, which is a value all the way up here. So it's like the starting value. It's like the starting value. It might be a little steeper than that. Yeah, it's probably somewhere like that. And then 3 minus x. So if I do 3 minus x, if I plugged in -2, 3 minus -2 is 5. If I plugged in -1, -1, 3 minus -1 is +4. If I plugged in 0, you get 3. If I plugged in, I think that's the pattern. So it's going to start at 1, 2, 3, 4, 5. So open circle. Then it goes to 4. Then it goes to 3. Then it goes to 1. Then we have an open circle there. And I know that I didn't sketch this good, but it's supposed to be a line there. And then at 4, that's just a horizontal line. It's y equals 4. So that's just a horizontal line. Okay, double check. The boundary's good. The graph's good. Open circle on this graph, so open circle, good. Closed circle, good. And so that's going to be what the sketch looks like. Now this one, just use your graphing calculator. So you're going to plug the function into your graphing calculator and just take a look at it. And you should be able to verify by taking a look at it if it has the extrema. And you're going to use it to show that it doesn't have any extrema.